In this video, I will create a class dedicated to configuring my controllers by providing each controller with the classes it needs after it has been created. You are currently looking at the class diagram for my OKReads application introduced in a previous video. We notice here each of the controller classes has an association to the data manager interface. Each controller just instantiates that interface to be a list data manager in their initialize method. But what if I wanted to update my application so that data was stored in a file or maybe later a database? Let me update the diagram and notice the file data manager class down here. I would have to go into each controller and update the instantiation of the data manager, change it from list data manager to file data manager. This is inconvenient along with some other problems. Instead, I want to have a single place where the data manager is created. And in the future, other classes which my controllers may need will also be created in this place. That will be in my new controller configurator. I have added the controller configurator class up here in the core package. Conceptually, the controller configurator is then responsible for making sure each controller gets the classes it needs to function after it has been created, instead of the controllers creating those classes themselves. We do this by passing in the data manager as an argument to a new method on the controller, or any other class they may need in the future. Notice I have changed the initialize method on each controller to an init method, which has a data manager parameter. You might say that a controller has a dependency on the data manager, and that we inject that dependency into the controller through a method. This concept is therefore called dependency injection. Usually it's done through the constructor of a class, but that will complicate things too much here. Maybe I will revisit this in a later video. So let's have a go at updating the code. The first step is to update each controller with that new method so that it can receive its dependencies. And yes, I realize I now have to fiddle with each controller, the very issue I wanted to avoid. But had I done my design correctly from the beginning, future changes would be simpler, like changing the data manager type. Let's pick the first controller, add author controller. I will find the initialize method here and just delete it. This is no longer how my controller class should get an instance of the data manager. Instead, I invent a new convention by adding a method. I call it init. I will add an init method to all controllers, which needs some class to function. In my currently fairly simple application, they will all just need the data manager. But in more complex applications, the required dependencies may vary between controllers. To this init method, I add an argument, the data manager. Notice it is the interface here, not the concrete implementation. This way, my controller does not know, nor does it need to care about whether it is working with a list data manager or a file data manager. This is the flexibility of interfaces. The parameter is just assigned to the field variable like so. And that's the update. Now my controller receives its required classes from somewhere else, whoever creates this controller. I will just go through the other classes. Next is the add book controller. Here I still need to load the authors and shelves too, so I now need that in my init method instead. Eventually, as the project grows, some controllers may require other classes than just the data manager, in which case I will just update their respective init methods. Okay, and now the controller configurator. I will create a new class here in the core package. I will add a method here, making it static because I'm lazy, calling it configure. And it takes any controller type, and therefore the parameter is just of type object. Then I need to figure out which specific controller I'm working with. I do this with an enhanced switch statement, where I switch on the controller type. I could have simplified this in this specific case by creating an interface with the init method and having each controller implement that interface, because currently all the init methods are the same. They all just receive that data manager. However, in the future, some init methods may divert. They may require other classes. So I will stick to my switch statement. And then the first case for the first controller, in which case the switched expression casts the object controller to an add author controller. That's my variable here. I can then call the init method on that variable. And this init method requires a data manager, as you should know by now. I wanted that single place of creation for the data manager. So let me create a method for that. Get data manager. The return type is the interface, but in the method body, I create an instance of list data manager. Then I just need to do the same for each controller type. Super fast. And finally, the default case, throwing an exception. And that's actually it. Well, almost, you will see. Finally, I just need to update the view manager. Here, in the first show view method, I have to update it to use an instance of the fxml loader, so I can get the controller afterwards. Then I can hand that controller over to the controller configurator. And then the second show view method, same thing, configuring the controller. Notice this should be done before setting arguments, because sometimes that method uses the data manager. For example, the view shelf controller. When it receives an argument, it loads the books for that particular shelf. I don't really like this. We call it temporal dependency. One thing has to be done before another. If I flip these around, it will not work. But I will think of a solution a different time. Okay, I think we're done. Let's just test it and make sure everything still works. And I get an error, of course. Interesting. So it turns out that one of my views does not have a controller. And in that case, the loader's getController method returns null. And then my switch statement requires a non-null argument, which causes the exception. So let me just add a guard for this case. If the controller is null, just return out of the method, do nothing. And retest, making sure all my views still work. And finally, a recap, what have we achieved? So classes that a controller depends on are now injected, meaning they are passed in as an argument instead of the controller creating them itself. This lets us benefit from the flexibility of interfaces. If I want to change the implementation used, I only need to update a single piece of text in the controller configurator, here. If I need to ensure multiple controllers are actually using the same instance of a class, I can keep that class in a field in the controller configurator for future use, and just return that whenever it's needed. I think eventually the creation of objects like the data manager should belong to yet another class. We could call it the service registry. I may add that later. I have not added the file data manager, but you can create that class yourself and just update the method so your application now uses the file data manager instead of the list data manager. But I have shown what I wanted in this video, so I will stop here. Thanks for watching.